Let's start with an assumption. Working in virtual reality is challenging. Not only you deal with a very high screen resolution, as a normal screen 2 centimeters from your eyes would appear extremely pixelated, but also with a very high frame rate. 60 stable FPS are the minimum for a VR game, and personally I consider that insufficient. Every time a VR game runs at that frame rate, I vomit on the floor. At the same time, seeing every object up close makes defects more noticeable, and so virtual reality often requires a greater granular level of interaction, more precise collisions, more interactable or physicalized objects, etc. While many games choose a cartoonish or a minimalistic graphic style to overcome these limitations, I, partly due to artistic choice, and partly because I'm just not skilled at creating cartoonish content, opted for a realistic graphic style. Given this choice, graphical compromises are necessary. Considering that realistically detailed sci-fi assets will typically be very slow to produce, especially at the level of detail I'm aiming for, and considering I'm working solo, it's amazing how a clever workflow can overcome these challenges. Therefore, the first thing I did was attempt to develop a working method that allowed a balance between asset creation speed, aesthetic detail, and rendering efficiency. I've created an in-depth tutorial explaining the method, which will be released in about a week. You can subscribe and click the notification bell to be alerted when it's out, but I'll give you a quick summary in this devlog. Essentially, there are 3 things to avoid when creating a 3D environment. Too many draw calls, which is to say too many objects or too many materials per object, overly complex materials, and too many polygons. To address all these issues at once, I've developed a rather advanced shader. The core of the workflow is a trim texture, which is a cornerstone of video game environment art. These are textures that contain many linear and repeatable details, or even individual details like bolts and vices, which can then be mapped onto the 3D model with appropriate UVs. This way, you can avoid the typical workflow of creating a low poly model, then a high poly model, projecting the details from one to the other via a normal map, etc. You have textures with generally better resolution and, more importantly, the same texture for many assets, saving memory. But that's not all. I've also created a system to have 9 materials in one, encompassing 3 metals, 3 plastics, and 3 paints. I've used the vertex color of the model to procedurally guide the presence of dirt or rust on the object, and the final result is visually appealing and very detailed, even up close, as the surface detail uses tile texture. Again, you will get a much more detailed explanation in the tutorial, but the final material looks relatively complex, appearing dark green in Unreal's instruction count, but this is a minor issue. Unreal's instruction count is deceptive, as not every instruction weights the same. The most computationally intensive action a material in Unreal can perform is reading pixels from a texture. The catch is that when it does, it also saves adjacent pixel in a small area to a cache, making subsequent reads in those pixels significantly faster. My system only uses a very low resolution texture, ranging from 256 to 1K, so there should be plenty of texture caching. This, combined with other small adjustments in the shader and lighting system, ensures that even the most complex scene, at a resolution above 4K, currently takes about 5 milliseconds, which is 200 frames per second. My rig is an NVIDIA 2080 and uses about 100-110 megabytes of texture pool. The 2080 is an excellent card, but I believe these are still very good numbers. To assist with modeling, as I work, I save every particular or interesting piece of the model I create in a file that contains them all, called a kit bash. This way, when I need to create a new model, I can just reassemble the components of previously created models like Lego pieces, and remodel only the strictly necessary parts from scratch. Regarding outer optimizations, such as lights, volumetrics, etc., we'll discuss that in an upcoming video. I don't want to overload you with technical stuff. Let's talk art direction instead. As you can see from these early images and the texture I created for this shader, I would like the art direction to convey an idea of wear, dirt, and density of detail. The world the player traverses should impart a sense of hostility and decay. It was a dreadful place to work well before hordes of creatures emerged to maul anyone. From this perspective, the main inspiration is Doom 3, to which I dedicate this floor. with an obvious touch of the Dead Space remake. The environment is mostly claustrophobic and dark, but sporadically I intend to strike the player with the vast yet equally hostile environments, inducing almost agoraphobia. Another goal I set is to give each area its recognizability. Certainly, the art direction is precise, and they are all parts of the same base, so they have their own specific style, but I want the player to have no doubt about being in, for example, an infirmary, or a section dedicated to liquid passage, or a warehouse. Even though mysterious areas are not lacking. In my mind, almost every particular asset has a purpose in the game world, but in some cases it might be less obvious to the player at first glance. Another important aspect of creating a setting is, of course, the lighting. In my case, I tried to use lighting and colors that complement the feeling the environment conveys, from abandonment to threat, mystery, and occasionally a moment of safety. Initially, to help me, as in the case of enemies, I tried to use the AI Stable Diffusion for inspiration. While the result was disastrous for enemies, and I had to invent the creature from scratch, in the case of the environment I had more success. For example, to create the initial warehouse, I generated a plethora of images, and for the final result I drew inspiration from this one. Even when the AI produces something useful for inspiration, it's always impossible to use it as a concept as is. You always have to do a reinterpretation job, as in this case. Many of these benches make little sense, but this one has some interesting details. I drew inspiration from it for the benches in some areas of the level, but it's evident that, apart from the resemblance in structure, all the details were changed, thinking about functionality. This is a headrest. This is a danger. In cases where I had something more specific in mind, the AI proved useless, and I had to do it myself. It's not its fault, it's just challenging to read my mind. When I had to create a tower, for example, I had a precise idea of how I wanted it, and the AI generated interesting but very different results from what I had in mind. When I asked for a Tesla coil cooling tower with a red eye and tentacles on top. When I didn't get what I imagined, I decided that I still had a very precise idea of the asset I wanted, and I did it directly. Similarly, for the second part of the level, and I will say for all the most evocative views, I used my imagination entirely. However, a minority of props are reworking of silhouettes generated by the AI that I found interesting, or are original models that incorporate some form of generative images that I like. All this predates the class action game Midjourney and the discovery that the AI not only steals artwork from the entire network, but from few and specific artists to train its skill. Personally, I think my use of generative models is relatively acceptable. Firstly, we are not talking about Midjourney but Stable Diffusion, which is free and open source. Secondly, and most importantly, in my case, the use made of it is equivalent to searching for references on Pinterest, something that every artist does. I don't like it, and I wish it wasn't so, but there is no world where a project like mine involves the use of a dedicated concept artist for each game prop, both because I would never have the money to pay for it, and because of the time such pre-production will take. If there hadn't been AI, I would have spent days on our station collecting graphic inspirations and creating a mood board to come up with something on my own, and the AI just accelerated this process. Still, I believe it's different from making direct use of content generated by the AI in a product. There is nothing created by the AI in my game. It was just about taking initial inspiration and reworking them, which still required a lot of work. I understand though that this is still a grey area, so around halfway through production I decided to stop using Stable Diffusion. But I still wanted to be transparent about the processes that were involved in the pre-production of the art in this level. The last, far less controversial topic I would like to talk about is the use of assets taken from packs. In my case, I used some objects from packs that Unreal has released for free over the years. They were very useful for filling the environment, especially the floor, with secondary objects that create detail, volume and cluttering without defining the main aesthetic of the area. Basically, everything that is the architecture of the environment is made by me, but most of the cables on the ground, smaller boxes, some generic cylinders or tanks, they are from packs. Some areas have a few of these objects, others have many of them, and some are essentially devoid of them. Except for these objects, in the end I found myself modeling from scratch about 120 unique meshes to populate the level. It was, as I mentioned, a huge job, but I believe it was worth it. I really want to show you the entire level, but I would prefer to avoid spoiling it for you. In reality, I think I've already shown too much. There are some rather captivating objects and props, of which I am quite proud. See you in the next video!